Set up properly. And then hit record. There we go. Right, so hello everyone. Welcome to session 23 of BGA24. And today we have Sibeli giving a talk on the GoaT-UI. So please take it away, Sibeli.
Hi, everybody. Thanks, Damon. Okay, so let me see how to start this. Today is actually one of the many different sessions that I'm going to be giving. Yesterday, we had a quick overview for what is GoaT during the EBP IT Standards Workshop. It was only 10 minutes. It was a bit rushed. So I'm going to repeat some of this information here, but if you can, you just go back to the recordings of that session and then you'll see a bit more than what I'm explaining here. Today is the GoaT-UI tutorial, and I split it into, this is the basic session that is similar to the one that I gave last year, just adding new features. But it's pretty much about the metadata that you can find in GoaT, mostly the genome related ones. So chromosome number, assembly, and I'm keeping everything that it's related to the EBP projects. So all of the project networks, how to see progresses, projects, there are lists of species, they are targeted by one project, whatever is in progress, what is collected. These all are going to be tackled in 2 sessions. There's on 17th and 18th of October. And so in this case here, I will try to make those 2 sessions the same. But if we run out of time, I might have more content in one and the other. It depends on how it goes with the people. But you feel free to attend both or the 3 of them. So with that, I'm going to just start saying what is GoaT. And I'm not really sure if people have used GoaT before, at least the people that are here. So it would be nice for me to see if you have the React button in your Zoom. Just let me know. If you haven't, just put a, because then I can give a more detailed explanation. If not, if I'm rushing through also, just let me know and then I can slow down and then redefine. Okay, there is at least one person that doesn't have not used GoaT before. So GoaT is some people say GoaT is a database, and it is a database, but I like to see GoaT more as a data aggregator. So it won't have the raw, like the real data, the sequencing data for assemblies. It is an aggregator of everything that you could possibly think that is going to be helpful for setting up a genomic analysis. So if you want to understand genome relevant data, metadata, you'll find this all collated in GoaT. So the idea is that we get all of this genome metadata put in a single place, that's GoaT, a data system, and allow all of this data to be independently and then searched and queried in any way, pretty much any way that you wish to. You'll see examples of this in a little bit, but this is really meant to help the coordination, definition, and tracking of these sequencing projects. It's about trying to see what is out there already, what is done data versus what is in progress, and let's try not to duplicate efforts. Let's try to save money in the process of sequencing all eukaryotes on Earth. So if you want to get more information, here is a link to the paper. Oh, yeah, I forgot, but here is a link to my presentation, so everybody can follow along. I'll give more instructions in a bit. But yeah, So what we see nowadays is, okay, there is a lot of information about genomes, a lot of information about chromosomes, but where can we find them, right? So we have a lot of the DON assembly sequencing stuff in the NCBI and INSTC. So ENA, the database of Japan, China, GenBank, GoaT, a bunch of different sources where you can go and actually access genomic data. But we also benefit from having information about the chromosome number, the genome size, I don't know, the status of that species in a country, if it's endangered, if it's not. So anything that can help you define what to do when sequencing a taxon, and I'm talking about eukaryotic taxa for GoaT, okay? It would be nice to have everything in the same place. So we have many sources, we have a lot of publications, we have a lot of dedicated databases, but they're all scattered. And some of them are really taxonomically biased. I mean, all of the data that is out there, there is like I was talking to Damon earlier before you guys arrived. For protists, we have almost no, everything is everywhere. So it would be nice to have a single place where you can find as much as possible. But what if there is no data, right? So GoaT is there to help with that too, because GoaT is, what it does is it generates estimates based on the values that are already there. So let's say that in the case of this case here, how much should we sequence, right? So the initiatives, they have a set goal for coverage of the assemblies. And it would be nice to know how much sequencing effort and how much money to actually invest and resources to invest when sequencing a genome, or at least making a choice out of, let's say, a species that has a larger genome versus a smaller genome within the same genus, and you have access to both. Well, let's try to sequence the smallest one first, right? That makes sense. So when this data is missing, what GoaT does is use some computation based on phylogeny, actually based on taxonomy, and then generates the genome size and the ploidy. There are estimates that can be used to actually calculate. Well, it's a much better informed decision than just out of the blue, just sequence a large amount and then you end up like over sequencing and using resources that could be directed to another species. So GoaT does that. What else is in there, right? We have metadata from DON sequencing that is not to be confused with things that are planned and in progress. But for instance, this is the next slide. But for instance, yeah, what assemblies are out there?
I think is people are asking whether, do you think are you supposed to be sharing the screen?
Oh no! I knew something would be crazy today. Share. I thought that I was sharing. Can you see
Yep,
my
there we go.
slides now?
Yep.
Great. Let's go back a bit so people can see my pretty pictures, because I didn't spend all of this time just talking about. These are the three different sessions, okay? Yeah, so yesterday we had this session, 15 minutes overview. Today we are having this 1.5 hour, 2 hour tutorial. What metadata can you find in GoaT? And this is genomic data, so assemblies, chromosome number, etc. And then there are 2 additional sessions to go over sequencing status, what projects are there, how can I submit data of my planning sequencing to GoaT. So these are going to be tackled tomorrow. This is the GoaT aggregator, and I was hovering my mouse here all over. Can you make sure that the beginning is also shown in the recording, Damon, so I don't have to go over everything again? So
Yes, I
just
can.
as a quick overview, so these is the sources that I was talking about. So we have many sources, many dedicated databases, and they're all over the place. But there is missing data. There is a lot of missing data, and there are taxa for which we have no chromosome number, for instance. So GoaT can estimate based on taxonomy to inform better, so people can take informed decisions when trying to sequencing something. So that's what I was meaning. For the sequencing effort, calculation of how much money should I spend sequencing this taxon, or should I invest in this taxon over a sister species? Let's estimate these two values and see if we're going to be wasting a lot of resources, or what is the best genome to pick, or best species to pick for sequencing, right? Or how much full cells we need for sequencing so-and-so genome. So this is the slide that I was at. GoaT also collects metadata from DOM sequencing. That's what I was meaning. We have INSTC open is anything that is all of the assemblies that are present on INSTC, so have reference assemblies. We have open for those that there are some sequencing data published in different places. Like, for instance, the Vertebrates Genome Project, they have a bucket where they keep the data before it's actually submitted to INSTC, to NCBI. So this is the case, but also, let's say, Chinese Gene Bank is not on INSTC. So if there are things made there, GoaT is collating them and labeling them as open. But besides that, there is a lot of pertinent genetic data. So the stats for the assembly, so N50, scaffold, Busco analysis, bioproject information, which bioproject an assembly has. I put bioproject twice because it's the bioproject for the assembly, but also the bioproject for Earth Biogenome Project initiative, so umbrella bioprojects as well. And yeah, this is, I really like transcriptome. There is a way to know if there is RNA data for your species. Okay, but you have to make the distinction between what is done data versus what's planned and in progress. And there where it comes what GoaT collates in terms of the projects that belong to the Earth Biogenome Project. We collate the list of possible or potential targets for all of the projects. So they declare a list that is like a wish list of what do I want ideally to sequence. And they keep track of that file, and updates are picked up overnight by GoaT. So on GoaT, you can also find the scope of a project, if it is high quality genome assemblies, if it is only short read sequencing, it depends on the project. There are different scopes. If it's only high C, for instance, but they want to collaborate. So this is nice to see because you can see what is in progress. You have all of the contacts for collaboration and GoaT. And as project managers, you can actually get your list, your original list, and then refine it by cross-referencing it with what comes out, right? Because at the same time, there is a lot of individual labs that are sequencing stuff and publishing. Instead of having to go and try to find on different sources, you can use GoaT just to see the status of that species. If it's open or INSTC open, it means it has been done. You might cancel the sequencing and redirect the resources to something else. And then solve duplication, because although there are 40-something projects on the Earth Biogenome Project, some of them have scope that are very overlapping. So identifying things that have been initiated, for instance, it really helps early on to define new collaborations, who has samples, or also if one project should just hold and use the resources for something else. Okay, so I was saying that GoaT actually estimates values, right, for missing data. So I wanted to give you an example before we start with the exercises today. And this is how inside, behind the scenes, GoaT is computing every single day a value or a summary value for a species that has missing data. So imagine that for genome size, we don't have the entire tree with direct observations, right? The genome size of, I don't know, Cnidaria is not there. We have some species that do have the observation, and we map it to the species. Then what we do is create summary values within a taxon. So let's say these two species here, they are congeners, so same genus. For genome size, GoaT picks a summary value that makes sense for it. So either a mean or a median. For chromosome number, it would be the mode of all of the observations and populate back in the tree with the summary values for the group. So that's what you see as the estimates from descendants, right? It will show up in orange. There is a color code in GoaT that you can see on the table when you use the UI. And yeah, so it goes back on the tree. Wherever there is no data, it keeps filling up with this summary value. And then what GoaT does is just it comes back, filling up whatever is missing data with the estimates from the most recent common ancestor node. And this is used to fill the gaps. So let's say that we have here these two species, right? There is this value, and here a full clade with missing data. What it did was it went back, populated all of these values, and then it returned and populated with the median all of these possible estimates. So in a sense, you get a color code, right, for how reliable the data is for a taxon. But also on GoaT, you can actually see how far back the estimate is coming from. So if an estimate is coming from the level of genus, like or family like this one, is not as bad as if it had to come all the way from, I don't know, phylum to fill up that value. Does anybody have any questions for now? This is the part that is a bit tricky to explain, but I guess just imagine there are estimates and there are summary values that are used to create those estimates. And there it is. So if you have the presentation link, you can just click on this. And from now on in the presentations, whenever you see a QR code, it's clickable. Most of the tables you can click and it's going to redirect you to GoaT. If you have two screens, I suggest that you just keep the my talk in one side or the slides, and then on the other screen you can keep the GoaT-UI, or you can always do side by sides in the same screen, because then you can see my presentation and then follow along. But there you go. So we have this is a bunch of bats. So you can see here that for this species, Artelius glaucus, you have no value for assembly span, but it's actually
Sibylle, GoaT is down.
No way.
The Sanger web services are down.
What?
That is the most incredible timing I've ever seen.
You know that happened last year as well, right? We had
Really?
We had to cancel. Yeah. Did they know?
Oh no.
Are they against the GoaT? So what should we do? Should we keep going or should we try to postpone? I don't know. Last year I ended up postponing.
Keep going for now.
Okay.
Just
I have some links that I had loaded before. So if I don't refresh them, I think I'll be able to show them. And for everything, I will have these like screenshots anyways.
It looks like they've got aware of the issue about an hour ago. They've got people working on it, so hopefully any minute.
But it was working just like 20 minutes ago, 10 minutes ago. Crazy. Okay. In the worst case scenario, if this all goes to not work, I can just, towards the end of BGA, just create another session for this, or use the UI first instance to do this one. The ABP instance, the session for ABP 1 and 2, I do this one, and the second one for the ABP. All right. So as you cannot see on the GoaT page, so if you go here, you have a list of species, right? You have different bats, they all in the same subfamily. You have assembly span, and you can see that for these two, assembly span is actually the length of an assembly, okay, in base pairs. So how big is your assembly? It's just the same nomenclature that we have for NCBI. So there is in NCBI datasets a glossary that you can find, and then most of the terms that we use on GoaT for assembly are in the NCBI datasets glossary page. I'll also put the link in the end of the presentation as resources for you. But anyways, you can see that there are two values here for these two species. They are in the same genus. So what GoaT does is create an estimate, a summary value, right? And populates, I think this one was made with the median, of all of the possible values for the genus, and then it populates back. So you can see it's in red. If you were on GoaT itself, you could hover over or click on that value and then see that it's coming, it gets a tooltip. So if you hover over anything on GoaT, most of the things on GoaT, you'll see a tooltip that explains to you what you are seeing. So always try to hover over because things will pop up. Anyways, and then for genome size, you can see here that there is this bar with the green and also the orange, which means that there are more values for subspecies coming from subspecies for this guy here. So it's nice to see that it actually creates a way to show you that there is direct value for the species, and there is also value coming from a descendant, and is usually the rank below. So in this case, it's subspecies. So can you tell me, if we are doing a search of all of the genera and we get a list of all of the genera, for all of these attributes here, what you'll see is just orange, because it's all coming from species. And then as you go up, you can see orange, but you can see also red. So orange is more reliable because it's coming from a data you can see, and red is coming from an ancestral. So it's probably not as reliable as this, but as we fill up the tree with data, GoaT with data, then these will start to change. As we pick it up and compute all of this again and again overnight, the more taxa and more data we add, it starts fixing itself. So this is just showing, I need to make a point because there is a lot of source of confusion on what is GoaT. So GoaT is a data system. GoaT-UI is a thing that people can go click and use, but most of the power of GoaT is here in the API. GoaT is a really complex system. It's based on Elasticsearch, so it's not like the normal SQL databases. It is independent. So if I have multiple observations, I have 50 files saying that the human genome is 3 point something gigabases, it's going to pick every single one of them. It will pick one summary value based on either a matrix, or if there is another source saying that that value is primary, so it should be the one displaying on your table, it will pick that one. So all of the data is behind the scenes. There are ways to get to it, but usually what you see on GoaT-UI is just a summary of what is behind the scenes. So let's say that to get to this value, actually for the species, not for the subspecies, it just got this value from 15 different observations. All of the 15 sources will be here. You can expand using these arrows, but you'll see a bit later, I hope, or tomorrow. So yeah, so the UI, it is a window to the features and capabilities of the API. And this is key to understand why GoaT displays on the web UI things the way that it does. So yeah, it is a window and it allows complex, simple queries like just give me all of the bat species and then a bunch of columns, or give me a list of all of bat species that are in the list of Darwin Tree of Life that have not started sequencing yet, but restrict those with only the species that have a chromosome number from 12 to 20. You can do this kind of search and exclude everything that has been published or is in progress by another project. So you can see that things will get bigger and bigger and bigger and bigger. And that's why it's so complicated to find an easy way just to summarize what can be done just in a search box that is GoaT-UI. But over time, as you understand what things are out there, you get a better sense of how to use these terms. So as you can see here, yeah, we have the GoaT-UI, and you can type things and get a table, and it will generate a link for you. So this is you start with the goatgenomehubs.org. When you type a query, it updates the search, and it will have a bunch of text back here that it's kind of the instructions to show everything that you see on UI. But if you put this simple term here, API and version 2, in the same link, you can retrieve the same data in a computer readable or findable format. So GoaT is trying to do these summaries, not in a way that only us humans can understand, but that computers can understand. And that's why the controlled vocabulary is so important. So now it's the time that I don't know if we're gonna get anywhere. Yeah, it's still down. So
yeah, apparently there's some problem with the data center entirely. So this may be for a while.
Okay, so let's do this. I'll go on for another, I don't know, 15 minutes, and then we see. But I would like you guys to give me feedback if you are it's too complicated to just see what I'm doing, because I planned the thing is a side-by-side thing would be much better to understand. But yeah, imagine that you can access GoaT and you go to the GoaT web page. That's the GoaT-UI, right? The first thing that you should be able to see is that the landing page has this tab up here, and I'll explain a little bit of what they do. So I'm not gonna go over the tutorials of every single tab, but we try to create content to help understand how to use GoaT apart from the publication. So here's the magic button. Anytime that GoaT stops working or there is weird stuff happening, you froze, you click here, you go back to the landing page. So you get a new search box where you can type stuff from zero. This thing here, it says latest, but it actually you can choose back in time how GoaT looked like. So let's say that you are publishing a paper in 2022, like the GoaT paper. We anchored all of the data and all of the links of that paper to that date, and we archived the data. So we are trying to keep archive versions every 3 to 6 months, so people can actually cite GoaT and create links that go back in time. So if you say there are 300 species of crab sequenced, of course, if you click on the link, it will show you the data live. But if you click a link and you select a version in the past, actually the link will be already with the version, then it takes you to those 300 species. So it's really cool because you can play with GoaT how it looked like before. What else? These two, the search and the help, we have a bunch of tabs. So if all those on the top are clickable as well. So this is a bit of confusion, but you can click on search, you can click on help, blah, blah, blah. And each one will have a summary or an explanation of what you can find in the session. But yeah, so there is a nice way to see a tree full of pictures here with some summaries for each clade. Templates, I'm working on it because I need feedback from people to understand what are the most used queries. So I can create templates and you just put a taxon name and then we can generate that for you, or the assembly, and we can generate a report or. And then here's all content to understand how to use GoaT. It's a lot of material. So we are creating now a wiki page, and we have also a YouTube channel where I'm trying to give you small amounts of GoaT, so it's not too overwhelming. And here is the session that's going to be explored in the workshop tomorrow and Friday. It's what projects are there and how to play with them. But you can actually click on them and then explore, see each project in the EVP community has its own project page. It has a subset of possible reports that people might want to use. As you see, the data is independent, but also you'll be able to see what is out there so you can start clicking around and generate things that you wish. And then here you can find all of the sources. And now we have this configuration button that allows us to pick user settings for the UI. And then all the way to the bottom of the page, of the landing page, you can find other things. So there is a way to pick your palette for the reports. Usually we have these colors, but that's not always the case. You can pick, for instance, we had the version for the Olympics with the colors of the rings. We have for Pride, we have some that are, let's say, colorblind friendly, etc. Here is, so you see where you are in terms of GoaT data, what was the last release. Aha. No, we didn't. I thought the GoaT was back. This part here, you can generate a QR code of any page that you are at. So that's why you have the fancy QR codes with the GoaT logo. These are clickable logos for our funders and the organizations that GoaT are part of. Then we have the cookie settings for analytics. I know that most people remove or reject all cookies, but if you are using GoaT, it would really help us to try to see who is using, for how long they stay in certain pages, what they are looking for. So I can access this information if you allow all. There's no stuff about vendors. And then if there are any problems, you can create issues on GitHub. Okay. I guess you can go to the YouTube maybe. I created 2 playlists, including the BGA workshop for 2023. So you can kind of see an outdated version of this talk that I'm giving today. In the other playlist, I am trying to create something as how can GoaT help you today? So most frequently asked questions. And then I just show in a screen recording where to click to retrieve information. So this is all features that we are starting to implement now, and we'll be investing a lot in the user experience and feedback. So please contact us if you have anything to say about GoaT, good or bad, doesn't matter. But yeah, so GoaT has 3 categories of data. I kept talking about taxon, the species, the genus, and these are the attributes that you can find from things that are not assemblies. Well, assemblies as well, but from the different, all across the databases. So we have the genome size, C value, chromosome number, haploid number, ploidy, legislation information, regional lists. They have the direct and estimate values. But then the index of assembly is actually one entry is one assembly accession. So you'll get all of the metadata that is linked to that accession. And you can create reports and do the queries the same way that you do for taxon, but then now the focus is assembly. And then for samples, this is still in progress, but it would be all of the metadata that is linked to a biosample on NCBI and SDC. Okay, so a small pause now just to think that what are the types of results that you can get for using the GoaT-UI, right? So usually people arrive to Go, they type stuff, they go somewhere and they don't understand exactly where they are. So let me already upfront tell you, there are two types of results. There is what we call the record page, and there is what we call the search results. So whenever you find a table of things, this is the search result. Whenever you click on the index, if it's a taxon name, you click on it in the table, you will redirect to a page that is a bit like a bit like this. So this is the records page, and you'll have all of the information that you know that you can find for taxon. I don't want to mess with it. Yeah. Oops. So this was supposed to be the follow along. So whenever you go to GoaT-UI, you can see that there is the search box and the buttons that go with it, right? Yeah. So the indexes are here. You can click on this drop down and you can select if you want to see taxon, if you want to see assembly. After you do that, you can type your query. So the name of your taxon, and then hit the search button again, and then it will give you something about your taxon. One thing that you can keep in mind is in the taxon index, actually there are different ways that you can retrieve the data, right? Usually we just retrieve the species name and that's it, but anything that starts with tax in these operators, when you start querying on GoaT, the first thing that it does is that it assigns whatever you type directly to this tax name. So it's the taxon name. It will return you one entry corresponding to the taxon that you entered. But if you change the tax tree, it will show that taxon and all of the possible descendants at any rank. So if you type family, then you'll see all of the genera, and then you can see not a list of species, but a list of every single entity that is a taxon and all of the data, including the summaries along with it. The tax rank helps us minimize this mess. So it's using combination with tax tree to say, okay, I want all of the Chiroptera or all of the eukaryotes at the level of family. So then you get a list of families. The tax rank just helps you refine all of the eukaryotes at the level of species. Then you get 1.8 million entries. It's there for you. And then tax lineage is a list of all of the ancestral taxa that are linked to that taxon. So if you say tax lineage equals Phylostomidae, which is a family, then you get Phylostomidae and everything that comes before it in the NCBI taxonomy. So far, so good. Does anybody have any question? Is it clear, or should we just try to follow along next time?
It all makes sense to me.
Anyone that has not seen GoaT before is getting very confused. Because I get my worries that it's going to be just a lot of information thrown and you can't click on places and it's kind of boring. But yeah.
It wouldn't surprise me if it doesn't come back today at all, because it looks like this is a systemic problem from yesterday.
This happened last year and it went on for 3 days.
Yes.
So worst case scenario, we have to cancel everything and just start in a different week. Let's see. Okay, I'll keep going because nobody said anything. But this was our exercise. I'll try to see if I can summarize it using whatever I have here. So imagine that you are in this page, right? In this search box. If you just type your favorite species, let's say my favorite species are all bats, so I forgot my example. But I don't know, C. elegans or whatever, and the naked mole rat. Oh yeah, the Amphioxus. Yeah. If you have selected the taxon, the index taxon, and you click on top of the name of the species once you get the table, then you see this page here. This is the records page that will tell you everything GoaT has on that species. It starts with, oh, does it have an assembly? Yes. Has it been annotated? You will have some I don't want to say ribbons, but some tags that shows it in terms of genomes, where is that? So if it's the first one of the family to be sequenced, you'll have like a label, boom, first of the family, first of the genus. So it's really cool because you can see things in colors. This is a phylopic that will redirect to phylopics and the source of the image if you want to use. This is all open source sources that we use from GoaT. And then all of these buttons here, it will take you to that entry on the different databases. So because this is a taxon index, if you click on UCSC, it will take you to whatever the species has as a primary value for the UCSC genome browser. So for NCBI, the same. So if it had, I don't know, 30 genome assemblies, it will take you to the one that is listed here. Do you see that there is always a primary? I'm sorry, I cannot show you down below, but there is always a primary, and that's where you go when you click any link out. Whoops. If you go to the assembly index instead, here it is, you can actually use the search box and query the taxon name, the taxon lineage, any of the taxa operators, but you can also just type there an accession. So if you type the accession, this is what you get back. It's everything that GoaT knows about that assembly. So has it been ran through Blob Toolkit? Yes, here is the snail plot. If you click on the Blob Toolkit link, it's going to take you there to the actual blob plot on the Blob Toolkit page. And then also, since this is no taxon, you can actually go see the entry in the NCBI datasets and also the taxonomy. So there is a lot of information in these record pages. You can get, if you're just studying that species, remember that there is a link on top when you do a search on GoaT. You can just put API v2 and then it retrieves everything for you. And remember, these are all summary values, right? Or one picked as the primary one for display. If you want more data, you can always get the raw data and the tidy version that I'm going to explain a bit later. So yeah, records is one way to play with GoaT. The next one is a tabular list of taxa or assemblies or samples meeting the query criteria. So whatever you put on the search box, you'll get in table format, like I showed you before. But to get the best you can from GoaT, it's nice to use these query buttons here. So I think I have screenshots of all of them that will be able to show you a little bit how they work. But yeah, so the include descendants one, the name is kind of straightforward. If you type Canidae for the family of dogs, it will show you just a single result saying Canidae. And hopefully I have it here. Yes. So it will show scientific name, Canidae. If you click on Canidae, it takes you to the record page. If you hover over this, it will show you what each attribute actually means. Some of them will have longer descriptions. Some of them will be kind of intuitive, so I didn't repeat what it says. But genome size is actually genome size, blah, blah, blah. Assembly span is the assembly length. Yeah, so once you do that and you hit enter, I just typed candidate, it will GoaT will automatically find this for you. Tax name, it will find the NCBI taxon ID, and you'll just transform what you put here. So if you erase this candidate tax name and you only put the taxon ID, this number, there's the identifier and the NCBI taxonomy, you get the same result. So for some reason, if you do know all of the tax ID of your taxa instead of the names, you can just query on this numbers. Anyways, so include estimates is a bit tricky. So once you click include estimates, it will expand whatever you put there. If you put a candidate, it's a family. So it'll expand to show you all of the genera, all of the species inside that taxon index. Yeah, there you go. So it's still candidate. I included descendants. Now it went from 1 to 145. You'll see that there are subspecies, there's species, but also genera. And then you see the results for every single one of those entries. One thing that you can keep in mind is that here include estimates is on, right? So you see 145 entries. If you do not leave include estimates on in this general table kind of environment, what it does is it looks at all of the columns that you have, and per taxon, it's going to display only the rows that have at least one value that has been a direct observation. So it is column agnostic, but it depends on how many columns and which columns you have displayed here. Let's say that if you remove haploid number, the column, then it will just focus on the other columns, and then maybe even the results will be less species. So it makes the decision per row based on what you searched. There is a better way to do this, both with the query terms, but also using this toggles, I guess, per column. So what I usually recommend is that if you just want to see what's out there and you're still exploring, you put your taxon, you leave both on, you'll see everything that is possible on your taxon. And then you can just say, okay, I want just a list of the species. Remember that the goal for GoaT is a list of species and then showing whatever they have on the column that you are selecting. But I want a list of species that have an assembly. So we use assembly level as proxy for, yes, it does have an assembly, because if it doesn't have an assembly level, it doesn't have an assembly. So these buttons here, you can click and unclick and select any combination of them. But for instance, in this case, I removed any row that was a missing value and any row that was an estimate from ancestral, if there was one. And then you can see that now I have 24 hits, but that means I have a list of 24 species that have assembly level. They have an assembly within, not species, sorry, 24 taxa, in this case, still including genera. In total, they have an assembly. So far, so good, right? And what if you wanted to retrieve a list of all of the candidates that have not been sequenced, right? So what you can do is just come here to the same query, same column, but instead of clicking here in the red and the black, you just disconsider the green and the orange. So it's going to remove anything that is direct or estimated from descendants. In the end, it will give you a list of species and subspecies from NCBI taxonomy that does not have an assembly. So this list is going to be massive, right? All of the taxa, including the hybrids, anything that is a candidate for NCBI taxonomy is going to be there. So it's going to be this huge list. But it's good because if you're a project, let's say, well, I want to sequence something that nobody has done before, right? I don't want to be resequencing reference assemblies. Okay, I have this list of whatever hundreds of species. Now, how can I pick something that is more interested to me? I can select, okay, let's get then a list of all of the candidates that occur in the country, in Brazil. There is another column that's called region that you can actually select per country code. So then for all of the species, according to GBIF, that occur in Brazil, which ones don't have assembly? So you already refined your list in a way that you know all of the taxa that you can potentially sequence that hasn't been done by anyone. And then this can go further. Okay, it hasn't been done by anyone, but is anyone actually doing it? You can refine using another column and then clicking accordingly. So in the end, this search box here is going to be bigger and bigger and bigger and bigger because GoaT automatically, whatever you do on the table itself, it automatically regenerates the link and regenerates the search terms on the search box. But with that link, you can always go back and check later. If you're not ready to do anything yet, at least you have the link that will tell you, okay, which dog species in Brazil are not sequenced yet, and no one is working on it. So it's really nice to just plan the work that you're going to do. And for those that don't like just typing on this search, because the how to say, terms that you use in the search box, they are very scary for someone that it's not used to databases, right? So we have here the result columns where you can select which columns you want to display. That's straightforward. But if you click in here, maybe I have it here, yes, you'll get all of the possible columns by category. So inside genome size, there is, I think, 5 different types of attributes. So genome size from k-mer counts, genomes estimated with k-mers, genome size based on c-value method, and then you can put in combination. You can say, okay, give me only results of genome size of Fuegen, whatever in flow cytometry of the taxa. You can select those columns and then click on everything. If you are brave enough, you can actually use the query builder to do it. Maybe I have it here. Yeah. So the query builder looks like this. You will see just one row up to here, I think. But as you pick more values, more fields, then you can increase the conditions that you are querying at. So here, for instance, I have candidate. This is in the taxon index. For the assembly, it's slightly different. But yeah, so I can type, okay, I want a candidate. I want to include descendants. I want everything at the species level. So this is much easier than be typing on the search box, candidate tax, name, candidate, and tax, rank, species. So if you just come here, just type those and hit update, it's going to create the table for you. But here, it's nice because you have all of the options kind of pre in drop downs for you. So for value, we have the actual value that we want to restrict the search on. For some of the attributes, you can actually get max and min. So give me the max genome size equals or 2. I don't know, I'm making that up. Chromosome number. Max chromosome number equals 2. So it will give me a list of all of the candidate where it has maximum chromosome number of 2. Of course, it's going to retrieve nothing. But if you put whatever, 60, it might get something, right? And then we have all of these operators. So greater than, and equal. So just like any other database that you can refine the search. And in this set of slides, I actually put together what each of them mean for you, but if you hover over, usually you can see what they mean on the GoaT-UI. Come on, Goat. No. Time to hear about you again. Are you comfortable with the workshop as it is? Are you okay to keep going? Especially the new people? Yeah, I'm happy. Okay. Oh, that's great, Kiara. Thank you. Okay, so this would be the second exercise that you would actually be clicking to see how you can retrieve data, but also how you can break the UI, because sometimes there are choices that you make in GoaT that they are not valid, and then you get like this horrible page saying something went wrong. But it's a good experience to just go there, type your taxon, start clicking things, open the query, the query box, how do you say it? The query builder, and just try to put things in the pre-filled version and hit update to see what happens. Right. So here was for you to just see that if you add or remove the columns, you might be able to see the list increase in number of taxa or species, or decrease, because as you add more columns, you're potentially adding more data, right? Data observations. So maybe there is one species that doesn't have data for anything else that you had before that now has data for this column. So you get a bigger list and bigger and bigger and bigger. Or as you restrict, usually what some people do is that they just, to avoid confusion, they pick one column, that is the column of interest, and they just look based on that column. And then that makes interpretation of the results a lot easier. So, well, you have this, so you can click around anytime you want with the presentation. I'm so sorry. Okay, and now we have some additional buttons on the columns that can help you filter data even more. The cogwheel here is actually allowing you to show or hide a subset of columns. One of the sources of a lot of confusion for GoaT is that they get this list of chromosome number, they download it, but they forgot to check which ones was a direct value versus what was an estimate, right? Because once you download the table, you have everything in that column, and it's not color-coded anymore. So to avoid that, we created this Richard is the one that actually codes for GoaT, created this cogwheel that allows you to expand. They will give you all of the possible expansions of column. But if you see here, I have chromosome number. It's the original search with the summaries. I have a column only for the estimates. It will show both estimates from descendants and ancestors. Only for descendants, only for ancestors, only direct, only the minimal value for observation, only the max. The mode, that's usually the one that I use to summarize the data. But if there is a lot of sources, each one saying that the chromosome number is a different one, it will pick the number that has been claimed to be the right number for most of the sources. Or the one that I have the power, because I'm GoaT curator, I set there as primary. So if you want a value to be set as primary, also you can contact the GoaT team, and then we set it as the primary for display. So then once you get this column here, you can see a direct value that you want. That is more accurate, I guess. But yeah, so you see, one column can turn into all of this, but it's still not showing all of the values, right? It shows the minimal, it shows the mode, it shows the max, but it doesn't show a list of all of the values. There is another way to get all of that. And it's usually only if you are really brave and you really want all of that data. But there are ways to get it, and it's with a click of a button. Under this table, you can download as a tabular file, like a TSV or a CSV that you can open on Excel, for instance. But you can also select a type of data that is the raw data, So it will give you every single entry for species, chromosome number, species, chromosome number, species, chromosome, every single observation with the different source. And then there is the tidy data that will also kind of transform and show you kind of summaries in a different way. I wish I could show you. But yeah, and then another button that you might see, this is for descriptive, like categorical data. If you click on it, you can actually see all of the options possible for that column for your search. So let's say here I put a list of species, right? And assembly level. So assembly level excluding missing data. So this is a list of whatever I was looking for species that have been sequenced. Yeah, okay, but at what level, right? And what level actually are there? I have no idea. I'm just using GoaT for the first time. Well, click on this guy here and you'll see now all of the possible values for your search expanding. And then it's easy to see when there is a dot, so we put dots. But this is more for, this is UI specific and it's just to allow visualization. But now at least you see, let's say that within your group, there wasn't any value for config. This column here wouldn't show up. So you'll see all of the other possible. The way to see what really is out there, just put eukaryota, species, and then you start expanding. You see all possible values for each column. I got a gift for these situations. I have a GoaT for stress occasions that actually, I don't know if you can hear it, but yeah, that's
Yeah, the screech.
I wanted you to be able to do this. But you see, under the tables, you have these raw values. And then you click on this arrow here, it will show you the drop down. You select whatever format you want to download. It will update this part here, usually says TSV because it's the most used. And then once it updates, you click on it again and you have a download. And I think I have downloaded stuff, a lot of stuff lately. So I might be able to show you how it looks like. How do I access my downloads?
I think it says 3 buttons.
Up here.
Yeah, I think it's, yeah, downloads.
Yeah.
Download 73.
Oh, and this is because I've been deleting my download. But if you see here, we have the taxon ID, taxon. This is actually the same. Let me put them side by side. All right, not you, this guy. Maybe I can increase. So whenever you delete, sadly, whenever you download stuff directly, so I think this was the tidy data version. So you see here that we have this species in a lot of rows. So what it's doing is actually going to, this is the species, assembly span, this value, this species, assembly level, scaffold, this species, assembly level, another instance of scaffold. This, so for this species, we actually have how many? Assembly level. 4 instances of assemblies, 4 different assemblies at different levels. So what GoaT does is usually it will show you the summary, so see here in the table, of the best quality or the one labeled as primary or reference genome assembly. So of course, there is a lot of others with scaffold. You can find this information in the records page and you can see a list of all of them. But that's how actually you see that this is actually a summary. And then whatever you have, this is the raw data. But you can imagine that for 1.8 million taxa species, to download always something like this will just make people completely crazy. So only if you need, pick your subset of query terms, and then you can play with this. But if you do want every single value in GoaT, you can get it. And then where is my 70? This one is the tidy data. The other one was the raw data. And what it's doing is it's showing you what is for each attribute. So for genome size, we have this value. It's coming from an ancestor, and it's actually a median. This one, chromosome number, is 70. It has been estimated by an ancestor, and it's using the mode. So you can tell where the data is coming from, but you don't need to really see all of the raw values, right? But in this case, you have the species and the attribute and the value per row. So different attributes per one row per attribute. Yeah. Is that clear enough? I'm still Englishing, I got it. Slideshow.
Yeah. I have good news for you, Sabelli.
There is GoaT.
There is GoaT. It may jump up and down a few times because I think they're still bringing services back online. But for now, we have GoaT.
Yay! Okay, what should you start doing? Can you? Yeah, I guess the most basic of the queries, right? Just go to number 1. You can actually. Does everybody have the slides at this point? Because what you can do is just get the exercise 1 and 2, and I'll give you 10 minutes to go over everything that I said, and then that's gonna be nice because that's the point that you will have questions and you will break things. So I'm here for 10 minutes. Is that okay? Yeah. I'll mute myself so I can use my GoaT. Do we have any questions in the Discord?
Not as of yet.
I lost my browser.
So will you be integrating the genome after party stuff? So like the Hi-C viewer and everything?
Sorry, I couldn't hear.
Will you be integrating the genome after party? So like obviously they're generating all the Hi-C maps for everything that comes through the pipeline. So will those end up on there?
What ends up in GoaT?
Yeah, because obviously you've got like the blob toolkits as a visual representation of the genome and everything.
Yeah, so for the Hi-C, we actually don't have anything because we are linking from the assembly directly to, the plan is to link directly to the genome node itself.
Right.
So then people can see. It's not like that yet, but we have it link out to the Darwin page. So let me show you here. If we go to, was this detail? Maybe not. Sorry. Everybody's using GoaT now. It's yeah. Oh, one thing that is I forgot to mention that it's a bit of a glitch, but it's fixed. But in the develop in the backstage, we're gonna make it live later. Is that the UCSC genome browser link? It works for the taxa that do have a value there. So I picked this one because it does. But if it doesn't, it will display the page of the last one that you found. And then a red bar saying cannot load, blah, 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 because it doesn't find the accession. This is going to be fixed by next week, but just in case people face this now. Yeah, so in this case, it's fine. But see here, a bunch of ones that I can't expand them and see who they are. But anyways, where's the detail? What is your favorite detail species?
I think Apis mellifera is a detail, isn't it?
Is it?
I think.
Oh,
Oh, maybe not.
so on the flyer, way to refine. Toolkit only. Yeah, it is in the list, but it's not done. No. Yeah,
Okay,
it is a
sorry.
It is open, but the one that published it is the Insect 5K initiative.
Right. No, there's Typhia femerata. There's Typhia femerata, the thick-thighed fly. I know that's a detail one because I'm the one that curated it.
Oh yeah, I cannot type that. My English it's gone, and my Latin is even worse. So let's try the one that I curated. Yay! Yeah. So if you expand this, you'll get to the records page for the species. And then there is the link for the Darwin portal here in this case. And then in the Darwin portal, there will be the link for the QC and everything that all of the data that is available. I guess in the future, we're going to be linking to the toll portal directly, because then you can get all of the information for in a single place. Here's more like things that have been submitted and are already open, but not the details of each data.
Okay, cool.
But here's the biosamples, so maybe, you get the full manifest. Yeah, but no Hi-C yet.
Okay, well, that's fair enough.
It's actually a good request, because then if I can link where the Hi-C live.
No, it can be a bit of a pain getting the link because it's an SPA. So there's
I mean to the genome node corresponding.
Oh, that one you'll be fine. But the other one, it can be right. It can be a pain.
And as usual, things are clickable. So you'll always have like in the summary page, if you hover over, you'll see a little bit more of information. My plan is to have all of this kind of documented in a searchable way in the wiki, but the wiki is still in progress. So, but yeah, I'm preparing it as I make the presentation, because then I remember what really we have. How to open all the columns for, okay. Yeah, so imagine that this is my query. Is Kiara still there, or did she leave before I noticed? Yeah, she's there. Okay, so let me make this bigger. So I just looked for my WASP, right? Here is the assembly level. If I click on not all of the attributes will have everything, but at least for the assembly span, for instance, assembly level, there is no point because it's not a numerical value. But for assembly span, I can go to the cogwheel. And then this is scary. Don't worry about it. This filled up thing is for features, but we are working on it. But you see here that there is subset. Here's the value. That's the one that we picked. But then there is min, max, count, direct, ancestor, and you would usually have to click out and then hit update. And now you have all of the assembly span values. And you can do for all of them, so at the same time. So if you want to expand genome size as well, you can. And by the way, if you do, let me see if I still remember the API, V2. This is the computer readable format, right? But if you actually put, let's see if I can go there. Ah. And then go all the way. How do I go all the way to the end of a link? I never do this. So cool. I'm just playing with something, see if it. No, I'll leave this for advanced code. But there is a way that there is a position here where you can add the data type that you want the link to give you. So I remember the term, but I don't remember where it goes. So if you put dtype equals TSV, then you retrieve a table directly. So no need to use scripts to transform the data from JSON to whatever. Okay, I think we have reached the 10-minute mark. Did everyone get somewhere, or is anybody stuck? Right? So I think I'll keep going. Or would you like me to show? I kind of showed you with the prints, right? The idea was the screenshot was in case GoaT didn't work. Yeah, so this is exercise 3. I think I'm gonna do this one so you can follow along. Let me do this. So make a species level search on GoaT that has a result with 1 to 10 rows. So what I'll do here is make a, where are you, GoaT? Help me. Can you still see my screen, or is it too small? Okay. So GoaT. See, whenever I click here, it goes to the landing page. I can always use the button to clear, and then I start in a clean slate. So here is, let's say, that's 3, right? And I'll use bats because I know them. And that's rank. You see that for these taxon related stuff, I'm using the brackets. But for all of the other attributes that are not taxon specifiers, we use the equal sign in the search box. Species, and I'll put here and assembly. Oh, yeah, and there is autocomplete, so it's not that bad. We're trying to make things easier. And assembly level. What this does, assembly level. If I just put here assembly level, it will show me everything that there is an artibius, there is a species, and that has an assembly level. If I want to refine it and put equal chromosome, I can, equal config, but I can actually do config, no, not config, config's bad. Scaffold, with comma, chromosome would give me a list only with assembly level meeting these conditions. I kind of already showed this to you just now. So, okay, we have a small table. Doesn't matter how we got there. The main thing is that you click here, you pick your type of file, and then you click again, and you get a new download. The CSV, I guess, it will open directly in my Excel, but you can get comma separated, tab separated, whatever. And then to get this from the API is just using adding the API and then the current version. Yeah, tidy data and raw I went to already. I guess we did the exercise 3 and I didn't even notice. Any questions so far? All right. Okay, so recap of types of results. We have records page, tabular list. There are ways to, let me see. We have the session here reserved for the 2 hours instead of an hour and a half, right? So what I'll do here is maybe give a break so people can rest. And then after this, I think I'm just gonna go over a few things and then we stop. Let me see if this. Okay, I'll just show you this usability improvement because that's pertinent for making your lives easier. And then we can take a break. Okay, 10-minute break for bathroom and water and coffee. So if you go to GoaT, and you usually have. Não, meu filho, não posso não. Ah. So sometimes when you use only the UI, it's really painful that you have to select the columns that you want to display every single time. Sometimes you use always the same query, but you just change the taxon that you are looking for the information. So what if you could just say, I select the assembly index, I put here my bat. It went to taxon. I hate it. Just force it to go to assembly. Of course, it's tax name, see? If I include descendants, it goes to tax tree, and now my index is every single assembly accession, right? And I don't care about scaffold. I just want, okay, and I have all of these columns. I don't want this. So I want to select only my assembly level, my bioproject ID, and my assembly type. Guess that's it. And assembly status, because I like it. Here, I can delete all of these other things. There are metrics, see the contact count, scaffold, blah, blah, blah. I don't care about any of this. Oh, we have even chromosome count. I don't want this, and I don't want this, right? So I'll update. Now I have a completely different table. I have 9 hits, but also I don't want, and you can see that in the assembly, there are no estimates, right? We only have the species because we have proper accessions. I don't care about scaffold. So usually the way that we do is, so assembly level here, see that we have some weird stuff. I think this is the Chinese, no, this is the organelle data. So you can just say remove the missing values. So anything that has an assembly level, it's a genome assembly, right? So a reference genome assembly. And now I see there is like some with scaffold. I don't care about those. And assembly level. So it's always the name of the attribute, then the operator. So not equal to scaffold in this case. So this is already starting to get complex query, right? If I click on update on the query again, so now it removed everything that was scaffold. And now I have my assembly type. So haploid means it's an haploid assembly. It's not the pseudo alternate haplotype. The assembly span is something I wanted, how many chromosomes they have, and then status of the assembly is just to see if it's primary or alternate. In this case, we only have the primary, and these ones, they didn't add the data for some reason. Okay, and then next week, I want to see this again. Well, I better just add search to favorites. So I just click on the heart. It's on my favorites now. If I go back to GoaT any other time, maybe now, and I click on the cogwheel up here, remember I talked about it. I can go to assembly, and there it is, Artivius and different scaffold. So you can expand this and hit search. So expanding is on the weird arrowy looking things. And if you hit search, it's going to take you there. Anytime. And the columns are actually the ones that I had selected. So you can always go back to your query, and you can save as many as you want, and you can actually edit. So for taxon, let me see. I'm now querying the family. Oh, and see what I did there? I don't need to retype everything. I can just delete and put the terms that I want. If I wanted to just equal scaffold, I can just come here and update and hit enter, and it would work. But yeah, so now this guy has 11 hits, and I saved it to my favorites. When I go here, let's open a new GoaT, it's always good. When I go to my cogwheel to find this query again, once GoaT decides to open, assembly, and I have the phylostometer here, you'll see that there is a QR code, so you can generate a QR code of your query and then send to people. If you click on edit, you'll see a bunch of things that you can actually, it's almost like a version of the query builder, but for your specific query. So here, yeah, so if you wanted exclude missing assembly level, you could add another one, right? So it's just a way for you to refine even more directly here. Once you're comfortable with GoaT, you don't have to do that. You can just do everything you want in the UI, and then once you save, it's going to be here. But it's good to always come here and see what changed, because then you get more aware of what it can do. And there is also the defaults. If you see here, for me, it's only the size. If I edit, I can put size, let's say 100. save the changes. It's always clicking again. It really needs you to click. So then next time that you go and do any query on GoaT, instead of the 10 per page, I'm gonna get this, the 100 per page. So you can see and scroll everything. So that's it. Do you have any questions about this part? Okay. Else. So yeah, now let's maybe take a, what time is it? 33. We'll have like 30 minutes left. What I'll do is that we can take a break. We come back and I'll talk a little bit of the misconceptions about the data. And then we stop there, because then everything else that is about the project pages and then the reports, I can talk tomorrow. All right. Okay, so now 10 minutes break. We'll be back 35, 45, huh? 15 to. All right, see you in a bit. I guess I don't have anywhere to go. So if you have any questions in this 10 minutes, I can also take them.
The saved search queries, they rely on you allowing cookies for the website. You're muted.
I know, no. Well, you can reject all and still get all the functionalities. It's just that for user experience purposes. So this was kind of mentored for the Sanger servers.
Mm-hmm.
But
Okay.
other than that, it just keeping the cookies just helps us try to see where and how the people are using and where they're coming from.
Yeah,
Like
no, that's fair.
which pages are linking to GoaT.
Yeah.
Oh yeah, so let me show you. So far we have all of these. You see that here we have 14 hits of I don't want scaffold. Okay, 25 hits of assemblies for this family. If we go back to 2022, we have 16. Huh? Yeah, that's it. And then you can always see that you are in the past here. It was so sad there were no colors. If there is anybody there feeling adventures, you can always click on these things to see what happens. Sometimes it pre-generates for you some data. So table gave me this. Of course, it says count of undefined, but for assembly level, we have 14. So summary data. Scatter, I don't think it's going to find because you have to define X and Y. I'm going to go over those.
Okay, that was something else I was going to ask later on as well. Whether or not you have accessory scripts, so I can do a query and then get some basic statistics to cover the whole thing. like how many have a scaffold and stuff like that, but it's built in.
Yeah, so we have a few types of reports that you can use, but it's just kind of most common ways that people look at data for summaries. So ideally, it's just download the TSV and go really plot or process the data. But it's good to see, like, I mean, so 14 assemblies are scaffold and 11 chromosomes is an ugly plot. Maybe I can do something good and say, oops, let's see if anything happens. Yeah, now we have the number per, but these are not all of the genera. So I can expand, say, give me, I don't know, 10 categories of more. So now it's giving me more. It's grouping everything else as other, and still ugly. Stacked. Oh, uglier. But what I wanted to show is it's really silly, but it makes so much difference. You can actually choose your colors. I like magma for the high C. So you can create weird stuff. And there is all of this, right? Anywhere that a tooltip comes up, you can click, and then you can see what has been done to the data to generate whatever report. Well, yes. Let me see if I can find. I'll paste this in the chat. It's one more resource. Five more, no? 5 more minutes? Is it? Okay, do you have any other questions? I might just activate my GoaT. It's okay. Sorry.
It's such a ridiculous thing. It just means it has to be something people get for their desk.
And I don't know how I came across this thing. I guess everybody that knows about me and GoaT, they just keep giving me weird stuff. My cat didn't like it particularly. Might as well find the erga. So how does it work? If I paste something on the chat for the call, will the link be available on YouTube as well? No, right?
No, it won't. No.
Sorry for the. Yeah, so that's what I need.
So what is it? The YouTube link that you just posted? I can stick that in the YouTube chat.
Yeah, I can create a small summary for you to put on the video. And also I'll update the page for the. But what I was trying to find is that there is a survey that we made. Because I want this link only for the people that are attending now.
What, sorry? Oh, right. I can stick this in the YouTube
I think it's,
summary as well.
but I don't know if it's because since it's a form that people can submit things, I don't know if it's like in terms of safety of.
Oh, maybe.
Yeah, I know that with these forms we have more control, but anyways, it's best to maybe send this as an email afterwards with the attendees. Do you have a list of everybody that enrolled or showed interest?
90% of them, yeah.
Okay, so then I think it's best that I just send them like the mailing list separately, if possible.
Yeah, that's fine. Yeah, I mean, at the end of BGA, there will be I'll be sending everyone an email that'll ask for feedback or BGA things anyway. I can tack this onto the end of it,
Nice.
just for specific sessions that I've asked for specific feedback.
Awesome. Yeah, so we're trying to this is a thing that we had with the it's like a first use case for user experience, because I've seen there is a lot of misunderstanding of some of the features in GoaT. I try to kind of explain today a bit, but still, so I want to see if people get stuck, where they get stuck, what they don't like, and stuff like that, so we can improve the UI a bit. In 1 minute, what I can do is just. So the slides themselves, can I start again? Is everybody back? Never left. Nice. It's weird to see only Damon's face here. All right. You need to tell people that their faces are not going to show up in the recording for YouTube.
That's a good point. I didn't think of that. Yeah.
I'll do that next one.
Yeah, only Sibeli's face will show up.
Oh my God. Yeah, so from the slides 40 all the way to 46, and there are two exercises actually. It's just a little bit more information on how the operators are, what they are and what they do, right? It's just so you have an idea. And then for those exercises, I actually have a result link that you can click and check the answer. So I'm gonna skip them for today, but feel free to write me if you cannot or something weird happens with GoaT. But one thing I wanted to show is this button. It's new. It's behaving not completely the way we want, but it will. But you can start doing cool stuff with it. So here is a mammal vertebrate query that I did. It is all the vertebrates at the rank of species. They have chromosome number greater than 30, and the sequencing status is either non-existent or less than in progress, which means sample collected is available and also nothing is also allowed. What if I wanted to just do this part? We're trying to make this a bit easier. So you see this button here? These are the filters per column. When you click them, it actually shows what you filtered on under the column. So you have an idea of what you were looking for. The idea, and it used to work before, I don't know what weird stuff happened, is that instead of going to the search box at all, you can actually come here. You see that if you click on it, suddenly it appears underneath all of the columns. This is transposing the query that we did on the box, but ideally, even if I didn't put that there, I would be able to just come here and set the value. So let's say I don't want 30, I want it to be different than 30. I would be able to come here, type that, and hit enter, and it would update. It was working before. It will work next week, but it's not working today. Let's see. Not equal to 30. Please. No. So it's just going back to whatever, the search box is still powerful right now. It just dictates what it wants. But at least you can see here, and then you get familiarized until the day that you can actually type stuff in there. So less than in progress or no. But let's see here, maybe. No, this for numerical, you set the values. But let's say, okay, sequencing status. My request from the search box now is just that it does have a sequencing status, doesn't matter what. If I go here, you see all of the possible options to select. And then once this functionality is back, all you have to do is just click on one of them and it will be them. You can select the values or the operator also. But for now, I think it's not doing that. Yeah. But it's just so people are aware that this is a new functionality and it will help a lot with user experience. For now, you can just see what happens. And then finally, I guess we have 10 minutes. I don't know if people want to discuss things or if I can just talk a little bit about the misconceptions of the GoaT data. What do you think? You tell me what to do.
I was just trying to get a list of all Hymenoptera that are complete from DTOL. So to do that, would I need to use the sequencing status? Because I've just put sequencing status in and it doesn't come up.
All of the species, they are done by DTOL.
Yeah, and are complete.
And so usually as a proxy for the projects, I like to use the bioproject ID because then it excludes really everything else. So usually I put the bioproject and then I set the value. So I think that's yeah. And then you can see this is going to be discussed. I can hear people, sorry.
Oh no, I'm at a conference, so there's going to be a lot
it's okay,
of background
sorry.
chat.
Okay, so if you see sequencing status, this is going to be showing the latest status of the assembly for a species. So you can see that it is INSDC open. In progress means, so the columns are independent. It's actually good to talk about it because so anything that has been in progress ever has been said, okay, that species has a record of being in progress, is going to show here. And then if the DTOL showed once eventually that it was in progress, it's here. It helps us just to control the order of events. So it goes sample collected, acquired, in progress, blah, 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 all the way to INSDC open. So it's just what in progress, it means what projects had or have this species in progress.
Okay.
But sequencing status, there is also, the sequencing status specific to DTOL is another column. It would be sequencing status and then the project acronym.
Okay.
So you can get a column just for it. But I'll go over those in better detail tomorrow. But yeah, so I use bioproject or the INSDC open, no, open equals DTOL. Equal. And then it's the same result.
Okay, cool. Thank you.
Yeah, this only works if I have the translation from bioproject to the acronym, or most of the projects I do. Okay. So I'm just going to talk about some weird cases. And that's my cat with my goat. She hates it. And some people really hate it when the data is wrong, right? There are two different things. One is the data is really wrong, in which case I really need to know about it. And the other situation is maybe are you sure the data is wrong, or are you looking at the summary? Or are you looking at an estimate or something else, right? So sometimes not. It is not wrong. So sometimes you're looking at an estimate that is coming from phylum, and of course, a chromosome number equals 2 because it's coming from I don't know, a protist, a fungi. It's not a good idea for your vertebrate. Of course, it's not going to be like that for vertebrates, but you get my summary versus raw. A summary value is being displayed on the table as the summary based on everything that has been reported for the species or for the assembly. For the species, sorry, assembly doesn't have the estimates. So the estimate is used to create the summary. All of the direct values is used to create the summary using a metric that the curator had to decide. So if for chromosome number, I decided that I'm going to display the mode, and two databases for some reason put wrong data in them, and I have just another one instance, the wrong data will be displayed. What can you do? Or what can the curator do is actually flag the one that is more accurate as the primary. So it bypasses this idea of summary, and the summary will be the primary that I selected, the primary source. So for instance, for Darwin Tree of Life, we had a lot of plants that had the genome size wrong. It's just that there were so many estimates of genome size for that plant or a group of plants that the median was being reported as the summary. And of course, median, it depends on how many observations and then how many were polyploid or not. And it picks up independently that summary. So if you calculate the genome size of a hexaploid and a diploid, of course, you'll get the median with the weird number, right? So always try to find the raw values whenever you're unsure if the summary, whenever you get mad, help me. And then done versus plan, I think I'm going to go over this one tomorrow because it's more pertinent to the projects. But yeah, how long do I have? 4 minutes, maybe. I want to tell you about the curious case of the weird karyotypes of mammals. So GoaT, a while back, it was even before the last archive, the first archive that we have, was reporting all mammals with a ploidy of 4. So tetraploid mammals. All mammals reported because simply none of the chromosome databases were reporting diploid. So of course there is a huge bias just to say, okay, this is a tetraploid, this is a octoploid, and then the summary value was the mode, and most weird scenarios of species were tetraploid for vertebrates. So we got all mammals tetraploid. The way that I fixed it back then is I had to go to the Mammalia taxon ID and create, that's not ideal, but I had to create myself an entry saying that all mammals should be diploid. And that's how I fixed it for a while, until now we have one entry of a diploid mammal that is serving as the reference for the entire class. So you see that sometimes also there is a bias just because people don't report things that we take obvious things, right? So this is one of the ways, but yeah, ploidy was 4 and it's wrong. It's not really GoaT's fault, but let us know. So what you can do is go to GitHub. There is the actual project page. If you go to help, you'll see contact, and that will redirect you to us. But you can either use the templates already that we created, or you can open a blank issue, just complain, 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 and enter. Just pick your words carefully because I'm the one reading them. And also, it's going to be public. But yeah, and then if you are unsure if anything, you can always use the GoaT contact email that is also on the webpage. And then the curious case of weird carrier types continues when people say, it's wrong. How come? Set to haploid, how do you say that? Haploid of 7 has 70 chromosomes, but the haploid number is 18. Right? I think this one is kind of obvious, right? This is an estimate. An estimate based, if I go to GoaT, I can see back where it is. And that's because every entry for haploid number is done independently from chromosome number. Chromosome number is its own thing. Then you come here, you see that for this species, chromosome number 70 is a direct measure, and the ploidy is 7. So most likely that's going to be a haploid number of 10. Unfortunately, all of the databases, they didn't have specified that the haploid number is 10 for most of their observations, and GoaT had to compute how it could, right? Using the tree, not using the other columns. So that creates a lot of confusion because sometimes we have ploidy matching, it's chaos. Remember, the summary values are based on what has been reported for the species, and the accuracy is how many times that metric has been reported for the species. So that takes us to the genome size. So what is the best genome size? I have 1 minute. Should I stop now? Should I go?
I will have to go
So
because we have the Omar
let me,
session right active.
I can stop here. But the main thing is that always make sure that you are using all of the available information in GoaT to make your decision. I'll go over this tomorrow. And then remember that tomorrow and the day after, we have a continuation of this, but more focused with the projects and how they progress and complete and the reports. All right. Okay. Thank you all. Sorry that we got just in time. And if you have any questions, please reach out.
Cool. Thank you everyone for attending. Thank you, Sibeli, for giving up your time to do this. And hopefully I'll see you in the next one.